Hello students, I am Mazi Kingsley Udoji and I'm your mathematics teacher. For today, we'll be talking about indices. Of course, you've learned this in your GSS 3. When you have a number multiplying itself in multiple places, how do you compress the number? And that is what we are going to look at. It has a law. And on that, we'll be looking at laws of indices. Indices is the plural form of index. And what's an index? An index is raised to power. When a number is raised to power something. So that is, the power is the index. When it is the plural, when there are more than one, you call it indices. So today, what index form is the method of shortening the product of the same number. You have the same number in a product multiplication. So when you have A times A times A, how many A's do we have here? 3. So I have A, the raised to the power of what? 3. B times B times B times B. How many B's do we have here? 4. So it's B raised to the power of what? 4. So A and B are called the bases. They are the base. This is the base. And this is also the base. Then, and 3 and 4 are the indices. Like I told you, power. This is the index. In this case, is singular, and this is also the index, but they both are indices. Do you understand this? So let's proceed. Now we move to laws of indices. Some textbooks can give you 7, 8, 6. There are some laws that have some laws that have 2 embedded in them. So I'm going to be doing that. So we will have 7. So let's start. The first law is multiplication law. You can call it additional law or addition law. So now, what does it imply? When two the same base are multiplying each other, the same base multiplying each other with different power, a raised to power m multiplied by a raised to power n, what do? Pick one of the base, then add the index or indices as the case may be. So that's why you have m plus n. For instance, 2 raised to power 4 multiplied by 2 raised to power 2. What do we have? The base here is 2. The index here is 4. The index here is 2. So pick the base, then 4 plus 2, which will give me what? 2 raised to power 6. You can further simplify this. Now, division law or subtraction. So this with division. When a raised to power m divides by a raised to power n, the resulting quotient will be a raised to power what? M minus n. Watch, the index are subtracting here. The indices are subtracting here. The indices were adding here. Now they are subtracting. Why? Because of this division law. Now, let's take for instance, you have 3 raised to power 5 divided by 3 raised to power 3. This gives us 3 raised to power 5 minus 3. Where did I get 3, 5 and 3? The index or the indices. So then 5 minus 3 will give me what? 2. So 3 raised to power 2. You can further simplify this. It's okay. Now the third one, we have power law. You must see a raised to power m, then it's raised to power n. The m will multiply the n. So mn means m multiplied by n, m times n. So we have case like this where you have 3 raised to power 2 or raised to power 3. So the 2 just multiply the 3, which is 2 times 3. And then 2 times 3 is what? 6. We have 3 raised to power 6. Do you understand this? Let's proceed. Now the fourth law is called product power law. There are products here. What are products? Outcome of multiplication, a times b. Then they are raised to the power of m. Each will be carrying their power. This bracket shows that the power is for both of them, a and b. So we have a raised to power m, b raised to power m. For instance, 3x all squared. Watch the bracket. There is a difference between 3x squared and this. This bracket means the square is for both 3 and 2. So what do? You have 3 raised to power 2, x raised to power 2. And 3 raised to power 2 is what? 9. So you have 9x squared. Do you understand this? Let's proceed. Then we have zero index law. This simply says any number that is carrying the power 0 is 1. In other words, 1 million raised to power 0 is 1. 1 billion raised to power 0 is what? 1. So that is the law. Now we move to negative index law. That is law number 6. And here there is a small note here because of the nature of the law. It says when a base, remember this word, base, is raised to power negative. The base takes inverse. Remember this word, inverse. What's an inverse? When you have a number in your GSS2, you were taught multiplicative inverse and additive inverse. What's an inverse? Inverse is 1 over that number. So if it's a fraction, the fraction will interchange. You see it with me now. Now when we have a raised to power negative n, the inverse of a is the base here. The inverse of a is what? 1 over a. And then the power will repeat itself. Now look at the one I'm talking about. A over b. You have like 3 over 2 fraction. Now, the inverse of a fraction is the denominator becomes the numerator, and the numerator becomes the denominator. So that is what happened here. That is why this a over b raised to power negative n becomes b over a raised to power n. Watch, there is no negative here. It's n because it has taken the inverse. Now let's proceed. We are going to look at the example. We have 3 over 2 raised to power negative 2. Like I said, this negative here will cause this 3 over 2 to take inverse. And what is the inverse of 3 over 2 from what we have here? You have 2 over 3 raised to power 2. And then this bracket means the 2 is for both of them. So 2 raised to power 2 is 4. 3 raised to power 2 is 9. Do you understand this? Let's proceed. Now we have 3 raised to power minus 4. What is the inverse of 3? Inverse of 3 is 1 over 3. It's taking the shape of this. So negative makes it inverse. Then raised to power 4. And what is 1 raised to power 4 is 1. 1 times 1 times 1 times 1 is 1. 3 raised to power 4 is 81. Do you understand this? Now let's move to the last law of indices. Fractional index law. Fractional index law. Now, of course, this also has a note attached to it. When a base is to the power of a fraction, what is a fraction? A fraction is when you have a numerator and a denominator. So the numerator of the fraction becomes the power. It becomes the power of the base, while the denominator becomes the word roots. Roots. Let's take a journey downward. You have a raised to power 1 over n. Now this is a fraction. This is the base carrying a fraction on top. Like I said, this one becomes the power, and this becomes the root. Now you pronounce this as mth root. Mth root. Mth root of what? A. This is how you pronounce this. Mth root of A. Of course, raised to power 1 if you wish, but anything raised to power 1 is that thing, so I did not bother myself. Now, b raised to power m plus n. If you watch this, the difference between this is that the numerator here is always 1. But in this case, the numerator is greater than 1. When you have such case, that's why you have the denominator, it still maintains the same law. The denominator becomes the root, the numerator becomes the power. So you have nth root of b raised to the power of n. Nth root of b raised to the power of m. Do you understand this? Now let's proceed. Let's see for example. 27 raised to power 1 over 3. 27 is the base. 1 over 3 is the fractional index. So, following this law, you have third root of 27. And what is the meaning of third root? Third root means a whole number that multiplies itself 3 times to give you this 27. And what is that number? 3. 3 multiplied by 3 multiplied by 3 will give me 27. So the third root of 27 becomes 3. Do you understand this? Let's take a journey. Now, 27 over 64 raised to the power of 2 over 3. Fraction base, fraction index. This is taking the shape of this. So, of course, the 3 becomes the root, while the 2 becomes the power. So we have third root of 27 over 64 raised to the power of what? 2. What is the third root of 27? It's 3. Third root of 64 is 4. 4 times 4 times 4 will give me 64. And then the square, remember the square? So 3 squared is 9, 4 squared is 16. 4 squared is not 8. 4 squared means 4 times 4, which is 16. Do you understand this? Now, we have come to the end of the class for today. I'll give you a brain check, which I'll be expecting you to submit immediately. Simplify. 27 raised to power 1 over 3 divided by 64 raised to power negative 1 over 6. The second one, 125 divided by 1000 raised to the power of negative 1 over 3. You do this and then you submit. And I remain myself, Mazi Udoji Kingsley. Thank you very much.